the real sky looking due south with the moon front and center, Jupiter to the right or the west, and Saturn to the east or to the left, August 10th and 11th. Well, good evening, friends. Again, this is Dr. Jim Daly with Astronomy for Change, and welcome to our next installment of the night sky. Tonight is Sunday, August 11th, 2019. Looking due south, again, like we've been talking about over the previous several videos, we have this beautiful setting looking due south. We have Scorpio right here, Sagittarius. I've mentioned Sagittarius a few times already. It strikes you as a teapot, okay, but in fact, what the ancients had seen up here was a centaur. Okay, we see a teapot clearly outlined here, but the ancient Greeks and the Romans, they had a centaur who's going to launch an arrow directly at Scorpio the Scorpion. Okay, I don't think I've mentioned that in such clarity, but I wanted to make that clear. You can see the wide disparity in cultures and mythologies between the ancients and current day, present day imaginations and the application of mythology. Okay, so we have this beautiful setting looking due south. We have the moon beautifully situated just to the west of Saturn. Right here we have a waxing gibbous moon. Okay, we can see the moon here. We can zoom in. Pretty much what we see, this is a nice binocular view of the moon, waxing gibbous moon, and that's it. And over the next few nights, the moon will be increasing in phase. In fact, let's take a look at what the moon will look like tomorrow. We can do that here. Tomorrow will be the 12th, and the moon will be just to the east and slightly south of Saturn. And the following night will be the 13th, is when the Perseid Meteor Shower will be peaking. And although will be peaking, there is a full moon. The radiant point for the Perseids is going to be quite a ways away. It's going to be about 50-60 degrees from the moon, so you should still be able to see quite a few Perseids as they streak away from the radiant point. Okay, I just want to mention that the full moon and the Perseids actually correspond this year with the peak activity on the 13th. Okay, so that going back to today's date, go back a little ways here. We have Jupiter, the moon, and Saturn. And if we take a look, we can confirm, as we've talked about numerous occasions, take a look at the ecliptic and get a sense of the plane of our solar system. You can see the objects, all objects on our solar system will be aligned with the plane of the ecliptic, as we see here. Okay, set against all these solar system objects and everything you see in the sky is set against the galactic center, 25,000 light years or so away. Okay, if we remove the atmosphere magically, like we can do with stellarium, we can see that. Okay. Okay, so let's turn the atmosphere back on, give a more realistic view. The sun is set, and this is now just about 9:30 at night, looking due south. It's a beautiful early August evening. Summer sky is in full bloom. We look north here, you can see the summer triangle directly overhead. We have Deneb, Vega, and Altair, Cygnus the Swan right here, or the Northern Cross with the constellations on, so you get a sense of what that looks like. There's the giant swan high in the sky right here. Okay. Again, when you look up, our modern imaginations might not see these things, but this is what the ancients saw. And we talked about these constellations in a previous video. I just wanted a quick review because they're perfectly situated during the early to mid-evening, directly overhead. Okay, now we haven't done this. Let's turn the atmosphere off as we look overhead. You see how stark, look at the Milky Way, how beautiful, it just jumps right out at you. Okay. galactic center, sitting 25,000 light years away. So the light we see from this part of the sky here left 25,000 years ago. So the light we see tonight is 25,000 years old, or looking back in time, 25,000 years. The moon, for example, is only a second and a half. So the light we see from the moon is only a second and a half old. So it'll give you some sense of scale. You can use your mind, your imagination to look through time and space as we look at the sky. Okay, put the atmosphere back on for a more realistic view. What I wanted to do, everybody, is we published an article just yesterday in Astronomy for Change talking about some beautiful objects to look at if you have a modest amateur telescope or a good pair of binoculars. It's called a galactic relic, a globular cluster called Terzan 5. And if we take a look at this object, this is a beautiful globular cluster. Get a sense of where it is in stellarium. We can use stellarium to navigate and find objects in the sky. We open up the search window and we type in the name, Terzan 5. Click search, and it's going to take us right there. That circle right there, the rotating circle, and it gives you the properties of the cluster right here. Go back to it again. We can zoom in on it. It's very far away. It's 19,000 light years distant. So the light we see from that of those stars left that 19,000 years ago. Almost as far away as the galactic center due south we saw before. Okay, also it's instructive to point out, if we look slightly to the west, we see this region of the sky here. That's Messier 8. We discussed Messier 8 in the previous video. And we have that opened up here. Quickly we can show you that. Messier 8 is right here. This is a telescopic view. This is through a high-speed, fast high-speed camera. And if we look at the stellarium depiction of it here, we can zoom in on that. Okay, this is, zoom back out. And that's what we have. Okay, so zoom back in for a moment. We can compare this to the picture through the camera, the high-speed camera that we saw before. So here, let's do that. Okay, this is an interpretation of data, or an image taken with a high-speed digital camera right here, and what they call an astrograph. Basically converts a telescope into a high-speed camera, or a very powerful camera. Okay, so I'm going to zoom back out, go back to what we were talking about a few moments ago, Terzan 5. It's a globular cluster. Now there are a number of globular clusters in this part of the sky. Let's go back to Terzan 5 for a moment. Right here, it's situated almost perfectly along the ecliptic. With Jupiter, it's sandwiched between Jupiter and the Moon. You would need a very an observatory class telescope to observe this object. Okay, this image here was imaged with the Hubble telescope. This one here. That's imaged with the Hubble telescope, the Hubble Space Telescope. It's humanity's preeminent orbiting observatory. It has pushed back our understanding of the universe decades. The amount of data and imagery and understanding we've gained through the Hubble telescope has been, you cannot put a price on it. It's tremendous. Okay, so this is Terzan 5. Compare that to another globular cluster, Messier 22. Take a look at Messier 22. It's another globular cluster in Sagittarius. These are all in this constellation of Sagittarius. Let's take a look at Messier 22. Yeah. Take a look at this. This is a good wide field view of where Messier 22 would be. It's very close to Messier 8. We go back to Stellarium. You can find this one. Relative to Terzian 5, it's like right up in here. Very close to Terzian 5. Let's take a look. Messier 22. M22. Here we go. Right there. I'm going to zoom in on it. Zoom in more. Right here. So it's very close to where Terzian 5 is. Go back out. Now keep in mind, that's very close to the moon. See that? So if you have a pair of binoculars, you actually would need a telescope for that. Messier 22 is very close to the moon tonight. Terzian 5 is over here, and they're all very close to the plane of the ecliptic in Sagittarius. Okay, these objects are types of objects. 2 of them out of 3 that we just talked about, Messier 8, Messier 22, were in Charles Messier's object of catalog of non-cometary objects that you would catalog and not look at if you're looking for comets. So Charles Messier's interest was comets. So he made this catalog, and catalog the locations on the sky, and know not to look there. And that was object number 22, Messier 22, and Messier 8 was the Lagoon Nebula, was an emission nebula. Messier 22 and another globular cluster in the summer sky was Messier 13. So we talked about that in the previous video, and I'd like to take a look at that here. Down here is Messier 13. Now I took this image here through a wide field astrograph, what we call, it's an astrograph, it's a telescope converted to a camera, and this is the view you would see through a pair of binoculars. Okay, you can see the object here, Messier 13, flanked by 2 fairly bright stars. This is in the constellation of Hercules, which we covered in the previous video. There's a lot of these kinds of clusters, globular clusters, in the summer sky. We have M13 in Hercules. We have Terzian 5 also in Sagittarius. We have Messier 22. Well, that's a wide field view. Let's go back and take a look at the closer view, as you would see with the telescope. This is taken with the Hubble Space Telescope. Okay, this is the view of M22 that you would see through the Hubble telescope. You notice all these bright stars here. These are evolved red giant stars seen at a distance of 22,000 light years. Okay, stars very much like the beautiful red-orange star, so warm and friendly in our sky, called Arcturus, only 40 light years away. And we talk about that in our article we just published here. Arcturus. Why am I talking so much about these objects? Because, for example, Terzian 5 is a special case. It's what we call a relic. It's made up of stars that date back to the beginning of the universe. Arcturus is one of the 5 brightest stars in our sky, and it's the principal star in Bootes the Hertzman, which we discussed previously. But the point I want to make is this star looks bright. It beckons red-orange, warm and bright, friendly in our sky, because it's only 37 light-years distance. Whereas these stars, we look at Messier 22, these bright stars, you need the huge telescope like the Hubble Space Telescope to see these stars at the same distance, or in the same sense that we look at Arcturus in our own sky, so close. Give you a sense of the distances involved are staggering. Okay. Now our article goes on to describe Tertium 5, and let's take a look at a recent video put together, compiled from a series of images taken. We're zooming in on the Milky Way, the heart of our galaxy, the galactic center. Okay, zooming in on that region of the sky. Here's Messier 8 right here, the emission nebula Messier 8. Okay, we're zooming in on Tertium 5. You get a sense of how far away it is. Here we go, coming up on it now. And it's going to just merge into the larger image, the Hubble Space Telescope, coming up very soon. Here we go. Okay, that's Tertium 5, and that was taken with the Hubble Space Telescope, and this is a full resolution image of Tertium 5. Okay. Globular cluster in the constellation of Sagittarius. And this is an image produced using stellarium from last night. Okay, here's Saturn. The moon was here last night. Now it's just to the west of Saturn tonight. Okay, and Tertium 5 was right in here, along with Messier 22 and Messier 8. Okay, let's return to stellarium. So you notice we didn't really leave our setting. It's now not quite 9:45. Sunday, August 11th, and this is our sky looking due south. Okay, let's take a look east. Here, you see the Great Square of Pegasus rising here, and we're going to be seeing the Perseids. But here's the Perseids right over here. Perseus is just rising, the radiant point right here. Now you can see the distance here is quite a distance from the moon. So even though the moon is waxing towards full, which is going to be on Wednesday. Full moon is Wednesday this month, which will be the 14th. It's almost 90 degrees from the moon, so you still get a good opportunity to observe the Perseids, between 60 and 80 meteors per hour. You will see. Okay. Okay. So we talk a lot about the globular clusters. These are very interesting objects, basically looking back in time and in space, across enormous distances of time and space. Okay. Okay, I'm fascinated with relics, as they have a story to tell, a deep story of something very old, of a long-gone epoch, a bridge, if you will, dating back to a time when the universe was much younger and much different. Globular clusters are that bridge, that link. They're populated with very old stars, each a relic unto itself, with a story to tell of a time when the universe was much younger. Okay, I wanted to mention the summer sky has a lot of these. Messier 13, the famous one on Hercules. Before we wrap it up tonight, let me just quick show you where that is. Do a search, M13. We can look at the Hercules, the keystone of Hercules. Here it is. Here. Let's zoom in on it. Okay, Okay, continue further in. Now, if we zoom back out, here, let's segue over to a binocular view of M13 we were looking at before, right here. Okay, this is an image I took through a wide field astrograph of M13. Take a look at this same view, stellarium. You can see it's a very good rendition, very good animation of that region of the sky. There's the two stars that flank it right here. Okay, and this is what you would see in a pair of binoculars. Okay, although a pair of binoculars you might not get the little tiny points of light that you see here. It would be more of a suffuse cloud. Maybe once in a while you start to get a sense of the stars. But those bright stars right here that you see are stars like Arcturus, which appears very bright in our own sky here. This again, try to emphasize that sense of scale and distance, that these stars are evolved red giant stars, okay, who are like the sun, have gone through their hydrogen, are now burning helium in their cores, and because of that, in the evolutionary sequence, they've expanded to become red giant stars. This is what will happen to the sun in a few billion years. It will use up its hydrogen and start to swell to become a red giant star. Well, that's already happened in these stars that populate this cluster, and because this cluster is so very far away, we need a powerful telescope to even begin to see these stars, which in our own sky appear warm and friendly, bright, friendly, as nice as signposts that date back to a much earlier time in our universe's history. Okay, I go into describe in detail more detail of what these stars are like, more of the properties of these stars, and so forth. So please check that out. It's very instructive and kind of as a supplement to tonight's video. Okay, everybody, let's go back here. I'm going to zoom back out. And here's the keystone of Hercules. You can see it looks like a giant H in the sky. Let's put our constellations up. Here's Hercules. Everybody knows who Hercules was, right? He was played by a famous Hollywood actor, I believe it was Liam Neeson, in the Kraken. It was this great movie of the ancient Greek gods. One of them was Hercules, and this is Hercules as he's rendered in the sky here. Okay. And Hercules is located very close to the Summit Triangle, which is right here, Deneb, Vega, and Altair, right over here. Okay, so we get a sense, how do we find Hercules? Here's Hercules right here. Put the constellations back. This is Hercules, put the labels. Hercules, let's get a sense of where we are relative to where we were looking towards the south. So they were looking pretty much due west. And since we were talking about Arcturus, Arcturus is right here. It's high in the western sky. And it's not quite 10 p.m. Sunday night. There's Arcturus. Okay, we have mentioned Arcturus as an example star that would populate the globular star clusters. Okay. Go back to our starting point. See where Arcturus is. Here's our setting where we started. The moon, Sagittarius, and Scorpio, and over here is Arcturus. So they're all located, as you go out, step outside, look towards the south, southwest, you can see Arcturus, and you can see the beautiful scene right in front of us to the south. Okay, ladies and gentlemen, I hope you enjoyed this video. If you found it instructive, please like, subscribe, and share. Please let friends and colleagues know, those who would be interested, about Astronomy for Change. It's astronomyforchange.org, and we're producing these videos, 2 or 3 of them every week, instructional, educational videos, and for those who just want to get a better sense of the night sky and what's above you, with a little bit more of an in-depth discussion of particular aspects of the sky, Astronomy for Change is your place to go. Okay, everybody? Until next time, please keep looking up, and thanks for joining us this evening.